Introduction to electricity, voltage, current, and resistance. It's sometimes hard to understand electricity because you can't really see it with your eyes. It's not easy to picture what's going on inside a wire, but we can understand it a little better by comparing it to something we can see, water flowing from a pump sprayer. In this video, we'll use a garden pump sprayer to explore three important ideas that describe electricity: voltage, current, and resistance. Electricity and water aren't exactly the same. Electricity has to flow in a complete loop, called a circuit, but the way water moves can give us a good feel for how electricity behaves. Voltage, the push. Let's start with voltage. Voltage is like pressure, the push that gets things moving. In this sprayer, pumping the handle builds pressure inside the tank. If I only pump it once, there's barely any pressure. When I pull the trigger, the water just dribbles out. In an electrical circuit, low voltage means there's not much push on the electrical charges, so the flow, called current, is low. This battery produces such a low voltage that it is safe for me to hold in my hand. A 9-volt battery has more voltage. You may have felt this by touching the battery to your tongue. More voltage, more push. Now let's pump the sprayer many times. The pressure is much higher, and when I press the trigger, the water shoots out with a strong stream. In electricity, higher voltage means a stronger push on the charges, so, if nothing else changes, more current will flow. But here's the important part. Higher voltage also means more danger. Even the electricity in a home has enough voltage to cause serious injury or death, and industrial equipment can be far more powerful. That's why you'll see high voltage warning signs and covers over electrical parts. If a panel is removed for maintenance or wiring is exposed, stay clear unless you are trained and authorized to work on it. Those barriers are there to keep you safe from dangerous voltages. Current, the flow. If voltage is the push, current is the flow. In the sprayer, current is how quickly the beaker fills with water. When the push is strong, more water comes out in the same amount of time, and the beaker fills faster. In electricity, more current means more electricity is moving through the wires each second. Current is what actually does the work, whether it's lighting a bulb, running a motor, or charging a battery. Resistance, the restriction. Next is resistance. Resistance is anything that makes it harder for the flow to move. With the nozzle completely removed, the water flows easily and fills this beaker quickly. That's like having low resistance in an electrical circuit. Charges can move freely, so there's a lot of current. Now watch what happens when I tighten the nozzle. The water sprays out faster, but less water is coming out overall. It takes much longer to fill the beaker. The flow is lower. In electricity, adding resistance reduces the amount of current flowing. From these examples, we can see that more pressure or voltage gives a stronger push and can make more flow. More restriction or resistance limits the flow, even if the pressure is high. What we've done here is build a mental picture of how voltage, current, and resistance relate to each other. For now, just remember, voltage is the push, current is the flow, and resistance is anything that limits that flow.